Hello everyone. Yeah, so I'm Amrit Priyadarshi for MTech project. My MTech project is a stochastic modeling of IEEE 802.11 wireless network with general topology, and I am doing this project under the guidance of under the guidance of Professor Anurag Kumar and Professor Himanshu Tyagi. So my contribution in this project is that developing a Markov model for general Wi-Fi network, especially when more RTS-CTS mechanism are enabled. So to model, we are considering general Wi-Fi network, like distance between any two node can be arbitrary, but they should not move. Like we are not considering mobility, and transmitter can choose its own transmit power, and based upon how much interference it's receivable. Suppose A1 is transmitting to S1, and at that time S2 and AJ are both are active. Then based upon how much they are creating interference at S1, that will decide that A1 to S1 transmission will be successful or not. And this model would applicable to IEEE 802.11g standard, and the 11 and a standard with MSTU aggregation. So in our larger project, the aim has been to develop a control strategy for for performance and management of arbitrary wireless network. Towards such a goal, it is important to understand why Wi-Fi network perform they way do. We take the approach of developing a stochastic models for arbitrary Wi-Fi network. The model are based on an active set Markov chain from which the required performance measure can be derived, like a stationary probability and collision probability. Our primary purpose in this work is not to get a highly accurate estimate of the performance, but to develop a model that provide insight, correct qualitatively behavior and reasonable estimate of the performance. Suppose we are considering this network Wi-Fi and this network, and at the at least now no one is active, that we are in the state 5, and now A1 can attempt, and once A1 can attempt, then active state will change from 5 to A1, and that rate will be lambda A1 attempt rate into 1 minus the rate at which RTS attempt of node A1 fail when we node A1 in the state 5. So active state will change from 5 to A1 with a rate of lambda A1 into 1 minus gamma A1 RTS of 5. Similarly, after A1 become active, S2 can attempt, and active state will change from A1 to A1S2. Like that, we are getting Markov set 80, and from that we can calculate a stationary probability and collision probability. And yeah, to make to avoid complexity in this model, we are assuming many modeling assumption. And yeah, in this slide, I will show result of 2AP to STA that we are getting from Markov analysis when we are considering simultaneous attempt and hidden collision, and result obtained from Qualnet and NetSim simulation. So we can see that our result for 30, let's suppose for 30 milliwatt, throughput is 4.18 and 4.30 AP to STA and STA to AP respectively when we are considering simultaneous attempt, and it's Qualnet it is coming 3.72 and 3.82, like so and from we another simulator that is NetSim, we can see that 4.1G and 0 and 3.57. So they are reasonably equivalent, and equivalent same. So you can see all the result are equivalent to each other. So thank you. Now I will like thanks Center for Network Intelligence for giving fellowship for giving MTech fellowship, and thank you.